Okay, in this problem, number 19, in page 119, we have an aeroplane landing with an initial velocity of 360 kilometers per hour, which stops, that means velocity equals 0, in 20 seconds. They are asking us to determine the acceleration and to draw the velocity time graph. Here, a lot of you have the same mistake. You took this as the initial velocity and this as the final velocity. And it is very important for you not to get confused. So, how can you know when you read the problem? Well, the airplane was landing. So at the beginning it was moving. It is not accelerating to take off. It was flying, it touches land, it lands with this velocity, and then finally it stops. So stopping happens after a while, after 20 seconds have gone by, okay? Remember, because velocity is changing, we go from an initial velocity to a final one, then we know it changes, so we have a uniformly accelerated linear motion. Always identify it. And then they ask us to determine the acceleration, which makes sense, okay? So I wrote here the equation to find out acceleration, and I also wrote here SI units, so that to remind you that we always should use the international system of units, so that we don't get confused. So we have here kilometers per hour, and it would be nice to transform it into meters per second. So let's do it here. Initial velocity 360 kilometers per hour. So we change the kilometers into meters, and we change the hours into seconds, okay? So we remove the zeros, okay? And we have that this is 100 meters per second, okay? So we already have this in the international system of units. I'm going to erase this initial data so that I can write it in the most comfortable way, which is 100 meters per second. I can erase these calculations that I do here. And now it's time to determine its acceleration. So we know acceleration is equal to final velocity minus initial velocity divided into time. So we have final velocity, which is 0, minus initial velocity, which is 100, divided into time taken, which is 20, okay? So 0 minus 10 is minus 10 divided by 2, okay? So we have minus 5 meters per second square. So what does the negative sign mean? It means that it's braking, so it makes sense, okay? So this negative means that it is braking, frenando, okay? So it goes more slowly and more slowly and more slowly until 20 seconds later it has stopped, okay? So this is a very important mistake that most of you had when solving the problem. You took a positive acceleration because of this confusion, okay? So we already know the acceleration. I'm going to write it here. Acceleration equals minus 5 meters square second. I'm going to erase all these calculations. And what we're going to do now is we're going to represent the graph. So we write the axis in here, time in seconds, velocity in meters per second. And what we're going to be doing is to represent this motion. So we know we start at 10 meters per second and we finish at 0 meters per second. Each second we go 5 meters per second more slowly, okay? And it takes for us 20 seconds to get there. So we're gonna do this. So 20, 10 is in the middle, this is 5, and this is 15, okay? You can draw it in more level of detail in the middle, but I don't have a lot of room in the blackboard, okay? Velocity, we have to reach the highest one, which is 100. So no velocity is going to be higher than this, okay? So this is 100. So in the middle is gonna be 50, 25, 75, and so on, okay? Okay, so we're gonna draw this. So we know that at the beginning we were moving at 100 meters per second. So when time is 0, remember that there is a 0 here, velocity was 100. And when time is 20, velocity is 0. So we can just join these two dots and get the graph, which looks something like this. So this slope going downwards means acceleration is negative. So it is braking, okay? And it means that velocity is decreasing equal amount of value in equal space and time, okay? So this is why it's uniformly accelerated linear motion. With a negative acceleration means we're braking, okay? Remember that, very important. Most of you drew the graph the other way around and it is not correct, okay? See you in the next video.